second just to explain basically how it works, the way they will be waiting, they will be counting down, and the first device that will count down to what its time will exceed, it will be the next one, the next one to communicate, and the other one will wait for the communication to finish before they can communicate. And this is how basically how it works. Okay, but when you make the research, when you make some research, you will see they will talk about the backup time, and they will say that the backup time is random, so meaning that each device will choose a random time and each device will be waiting that random time. You understand? So it means that if PCA waits, choose what, 1 minute, so PCA will be waiting 1 minute before communicating again. You understand? So if PCD waits, decided to choose what, 10 seconds, he wait after the 10, he will only communicate after the 10 seconds that he have chosen. But now the time is random. They will choose it randomly, meaning that it will not be the same for all the devices that are connected to the hub, which makes it that there will be one device that will exceed its time first, and it will be the first one communicating, and the other one will be waiting. I hope now it is clear. Okay.
Yes, please.
Okay. So now let us okay. So I think okay. So concerning the hub, I think we talked about everything, so we can move on. Okay, so now you can see that with the hub we have a lot of issues. The hub has a lot of issues, and in today's modern networks we don't use hubs anymore. Okay, I'm not sure that you come across hubs in today's modern networks. Okay, so someone one day I was discussing with a colleague. He said that okay, he came across what one hub, but that hub was there. They would, I mean, years back to since they installed that hub, they never removed it. But it was very old hub. But in today's modern hub networks, you will never come across what hubs. We don't use it anymore in today's modern networks. Okay, so now because of the fact that the hubs was having a lot of issues, so they decided to came up with what, with another device. Okay, which comes which so which was solving all the which solves all the issue that the hub is having. So let me open a new window in new, okay, a new board here. So now the new device that will be the new network device that solves most of the whole issue that we have with the hub is what we call the switch. Okay, yeah, the switch. Okay, so now the switch compared to the hub is a smart device. The switch is not a big gadget like a hub. So the switch is a smart device. Okay, is a smart device. Okay, the switch is a smart device because okay, because it can learn information about devices that are connected to it, and it can perform what we call the forwarding decision. Okay, so now a switch has a database. It has a database where to keep information. Okay, a switch has a database, and that database is what we call the CAM table. The CAM table, and the CAM here stand for content addressable memory. Okay, and the switch, okay, has privacy. The switch has, okay, it has privacy. Okay, the switch, okay, has I think it has lots of ports. Okay, it has lots of ports compared to the hub. Okay, and then okay, the switch, okay, it supports two types of communication. Okay, so we have alpha duplex. The switch support alpha duplex that we have seen, and it also support what we call full duplex, and I will explain that. Okay, so now when it comes to the switch here, this is how we represent the switch. This is the symbol of the switch. This is how we represent it. Okay, the switch is represented this way. Okay, so this is how we represent the switch. This is how we represent the switch. So now, okay, okay, so now let's say that we have a switch here, and you have devices that are interconnected to that switch, which is here. Okay, and let's say that here we have PCA, PCB, PCC, and PCD. Okay, okay, and the switch here has one, two, three, four ports. Okay, and those devices are connected to the switch like this. Yeah, Pamela, you want to say something?
Yes, please. I didn't get the what the CAM stands for. You said content something. The spelling didn't come out well.
Content addressable memory.
Okay, addressable. Okay, thank you.
Content addressable memory. Okay, so now we have four devices that are connected to our switch here, and our switch actually has what, four ports. Okay, so now as I said here, you can see the first point I said here, that the switch is a smart device because it can learn, okay, sorry, it can learn information about the devices that are connected to it, and it can perform forwarding decision. This is what makes the switch to be a smart device. So now, how the switch learns information about the devices that are connected to it? So basically, when if PCA is sending information here, a message, okay, so if PCA is sending a message, okay, let's say that PCA is communicating maybe to what, to PCD, okay, PCA is communicating to PCD, but when PCA will send the what, the message to PCD, the message here will have some information. I mean, in the content of the message will have some information about the device that is sending, and the device that will receive what, the message. So it meaning that the sending device is PCA, and PCA will have its information in the message. Okay, so now when the message will get to the switch on its port 1 here, the switch has a database. Okay, has a database, and that database is what we call the CAM table. The CAM table. Okay, and the CAM table here, the first part of the table is where we have what, the port numbers. So we have port 1, we have port 2, we have port 3, and port 4. Okay, so now the other part here, okay, I can, okay, I'm not, okay, I'm not going to talk about it right now, but let's say that here we'll have maybe device name. Okay, so basically, when PCA will send the message, and the message will get to the hub here, to the switch here, sorry, the switch will understand that, okay, in the message that I'm receiving is coming from a device which is A, and if I'm receiving that message on my port 1, it means that device is connected here on my port 1, and that device which is sending that message is PCA, and he will take that information and put it in his CAM table, saying that, okay, PCA is connected to my port 1 because I received the message coming from a certain PC, and that PC is PCA, and he will take that information, put it in in what, in his database. But now when you will send that message, when you will send, you will take the message, you will send the message maybe to PC, okay, and PC, okay, maybe at a specific moment too, PCD, let's say that for instance PCD also want to communicate with another device, and when PCD will send the message, okay, the switch will understand that, okay, I'm receiving a message coming from a specific device, and that device name is what, PCD, and is connected to my port 2. He will put, okay, PCD is connected to my port 2. But now I say that PCA wants to communicate with PCD, so it means that when the message will get to the switch, and the switch will understand that, okay, we'll learn that information, that PCA is connected to my port 1 here, okay, to my port 1 here, and now the destination device is PCD. Okay, so the switch is going to look at what, the destination information in the message, and you will find out that, okay, this message I have to send it to the intended device, which is PCD. But where is PCD located? Okay, where is PCD connected to me? Based on the database, the switch will be able to understand that okay, PCD is connected. I've communicated before and I've learned that PCD is connected to my port 2. So it means that if I have to take that message coming from PCA and send it to PCD, I have to send it to out of the port 2 where PCD is connected. So automatically the switch will take that message and only send it to what? Out of the port where PCD is connected. So it means that now the message that is coming from PCA will only go to the right destination, which is D. The switch will not forward it or send it to all the devices that are connected, which brings what? Privacy and security. The hub was not able to perform that. You understand? That's why we say that the switch is what? Is smart device, because the switch was able to learn first the information of the device that is connected to its port, and now it was able to perform what we call the forwarding decision. And the forwarding decision is about sending the message to the right device, to the intended device only, and not to all the devices that are connected to the switch. How are we good so far? Okay, so this is what makes the switch to be intelligent, a smart device. So the switch is a smart device because it can learn information about the devices that are connected to it. It can perform for the forwarding decision. The switch has a database that we call the CAM table, okay, which stands for content addressable memory. It has privacy because the message is not going to everybody. So it means that if the message was containing confidential information or private information, only PCD will be able to receive it and process that confidential message. The other device will never receive it. Okay, so now it has lots of ports. Okay, so let me show you, for instance, a real switch. Okay, a nine. Okay, let me show you that. Okay, this basically, for instance, Cisco Catalyst. Okay, let me show you the Cisco Catalyst. So for instance, this is a switch from Cisco. Okay, so this is, for instance, a switch. You can see that this is a switch, for instance, from Cisco. Oh, where is it? Okay, you can see that here this is a switch. This is a switch from Cisco. This is the Catalyst 2960. You can see that this switch actually has what? I hope you can see. Are you able to see? I hope so.
Yes, we can see.
Okay, so this is the switch from Cisco. You can see that this switch has a lot of ports. Okay, lots of ports. Here, this switch I think has maybe up to more than up to 48 ports, I think. Okay, so this is the Cisco switch from Cisco. You can see how it has lots of ports. Okay, so now, okay, let me go back to my presentation. Okay, so now that's why I said here that it has what? Lots of port, and it supports two types of communication: half duplex and full duplex communication. So now with the switch, devices can send and receive messages at the same time. Okay, meaning that with the switch, PCA, when communicating with PCD, can when communicating with PCD, they can both send and receive at the same time without no problem. Okay, because the switch here support of both communication. Okay, the half duplex and full duplex. Okay, but now this concept or this fact of the switch that supporting both communication is per interfaces. Let me precise it. This is per interfaces. An interface, let's say that, for instance, okay, let me precise this. I will be saying interface. Okay, interface or port, but when I'm saying interface also, basically I mean the same thing. Okay, so this interface of the switch, I can also call it a port. It is basically the same thing. So now this interface of the switch, maybe where there is a device which is connected here, can support half and full duplex. Okay, now it depends on the device which is connected to that port. If the device, for instance, most of the time PCs, today's modern laptops, function in full duplex by default. Okay, but I mean, when I'm saying full duplex, the network interface card of the laptop function in full duplex by default. So it means that if the network interface card of this laptop here function in full duplex, it means that the port here of the switch also will function in full duplex. Okay, this is how it works. But now it means that the switch here will be sending, the switch and the hub, the switch on the laptop, the device here will be sending and receiving messages at the same time without problem. So meaning that this device here can send, can receive, and can send message data at the same time without problem. But now, if for instance you have, let's say that this is another port of the switch, and now you have a hub which is connected to that port of the switch. Okay, that port of the switch, you know that the hub only support half duplex communication. But now, because of the fact that the hub only support half duplex communication, the port of the switch here will adapt to the types of communication that the hubs here support. So because the switch, this port of the switch is able to support both half and full duplex, and the device which is connected to the port is supports only half duplex, so the port of the switch here will function in half duplex, and this is how it works. Okay, I hope it is clear. So now, but by default, if devices laptops are connected to the switch, they can send and receive messages at the same time without problem. Okay, but now let me also say that sending and receiving messages at the same time is not only between two devices, is two or more devices can send and receive at the same time. Two or more devices can send and receive messages at the same time. Okay, I hope it is clear. So the switch supports half and full duplex communication. Okay, so now okay, so now let us move to the other network device now, which is what we call the router. Okay, so the router is a network device which is used, okay, it is used to interconnect different networks, and this is how we represent the router. This is how it is represented. Okay, so now a router, it is used to interconnect the different networks. Okay, and the router, it is a smart it is a smart device. It is a smart device. Okay, and the router has it has a database, and the database of the router, we call it the routing table. The routing table. Okay, and the routing table here, the routing table, okay, which is the database of the router. The routing table contains, okay, information about the networks connected to the router, connected to the router. Okay, and then the router here, okay, also support, okay, the router also supports half and full duplex communication. Okay, and compare to the switch, and compare to the switch, it has fewer ports. Okay, the hub has fewer ports. The router, sorry, the router has fewer ports. Okay, so now let us talk about the router. Okay, so now let's, if you, for instance, you have a switch like this. Okay, let's say that you have a switch like this. Okay, and then this switch here, you have devices that are interconnected like this. Okay, you have devices that are interconnected like this. When you have a switch with devices interconnected like this is what we call, this is what we call a LAN, a local area network. Okay, This is what we call a LAN, which stands for local, okay, LAN, which stands for local area network. So a local area network is a net, okay, is a network in which you have what devices that are interconnected within, okay, a single geographical area, okay, within a single geographical location. Okay, it's just a bunch of devices that are interconnected within a single location, a geographical location, and this is what we call a LAN. For instance, at your home, I can guess maybe you have a wireless router, and that provides you internet at home, and you have what? You have your laptop, you have your phone, you have your I think your maybe your printer, you have maybe your smart device that are there also present. They are also connected to what? To internet through that wireless router. So now, okay, all the devices that are interconnected to from your home that are interconnected to that wireless router, they form what we call a local area network. Okay, and this is what we call a LAN, a local area network. So you can see that here we have a LAN, one networks. Okay, and maybe that this from maybe this is a specific network, but you can have maybe here. Let me call this one for instance LAN A, and I can have another LAN here, maybe LAN B. So, okay, and this is another network. Okay, where I also have devices that are interconnected here. Okay, and then you can see that this first LAN here belongs maybe to one individual, then let's say to someone, and LAN B here also belongs to another person. So those two LANs belongs to different person. But now if for instance those two LANs we want to interconnect them, maybe I want the devices in LAN A to be able to connect with devices in LAN B. Okay, to be able to connect with devices in LAN B, and making with and then making sure that they are different networks. Okay, I can decide to use what? A router. I can decide to use a router here. Okay, use the router like this, and take a cable, connect to the first LAN here, take another cable and connect to the second LAN, which is here. And right now I have two LANs that are interconnected to what? To the router here. Okay, so now you can see that here this LAN here, LAN A here, will be considered as what? As one network, and LAN B here will be considered as what? As another network, as a second network. So you can see that now on the router here I have two networks that are connected on this router, two networks that are connected to the router, and those are different networks that are connected to the router. And the purpose of the router is to interconnect different networks, as you can see. Okay, so now let me precise, different networks. I'm not saying the same network, I'm saying different networks, meaning they are not the same. So now based on that, if I remove the router here, let's say that I remove the router. Okay, let me clear it like this. Okay, let me clear like this. Okay, so now if I remove the router here, okay, and I decide to interconnect for instance those two LANs like this using a cable. So now those two LAN are now connected directly through a cable. Do you think that we still have different networks, or we have the same network? Do you think that we still have different networks, or it is the same network now? Hello. As I said in the beginning, I want this session to be interactive. Okay, so you have to participate too. What do you think, guys? Yes, Pamela, since you're the only one who is interactive in this session.
Okay, I think there are different networks,
Do,
because LAN A has its own switch and LAN B has its own switch. So they are different network. It's like two families, uh, Mensa family and what uh, Agri family. They are not the same family, but Agri family can come and visit Mensa family.
mm, okay, I see. But right now it will be different. Okay, right now will be different. Now, because of the fact that the switches are interconnected like this, we don't have two networks anymore. We have one network only. Okay, because what makes the network to be different is what is the router. Okay, and there's something else also that makes there's something else also that makes this to be the same network, but we have not seen it yet. But I hope there's professionals here that already have a kind of idea about IP addresses. Okay, you know what is an IP address, right? Okay. Hello. Do you have any idea of what is IP addresses? If no, it's okay. If no, it's okay. But we see it later on. But basically, based on there are some points that we have to take in account that will make us that will that will how can I say it? Okay, that will make us notice that okay, now when you interconnect those two LAN like this, they are now in the same what in the same network. Because if you want to PC, let's say that you want PC A, B, okay, C, D, E, F, for instance. If you want, for instance, PCA here to communicate with this PC here, okay, there are a lot of things to take in account. But there is something when we take it in account for PCA and D to communicate, it should be the same. They have to be in the same network. Now, when you interconnect the switches like this, okay, they are now in the same networks. Okay, they are now in the same networks. But if you interconnect them through a router like this, if you interconnect them through a router like this, the router will make those two networks to be indifferent. But even if they are different, the router will be able to take messages coming from this network and send it to the other network here, and the same thing from the reverse way. The router is able to do that. But now, if you remove the router, okay, and you connect them the two switches like this, and you want those devices now to do all those devices to communicate, okay, there is something that you have to take in account. But since we haven't seen it yet, okay, later on I will explain it. But when taking this thing in account, okay, you will notice that all those devices they will now be in the same network. And this concerning IP addresses, because when you would think about the IP address scheme, if you want all those devices to communicate, you have to give them the IP addresses coming from the same network. So it means that all those devices will be now in the same network and they will be able to communicate. You understand? So now they are in the same network. Okay. So now switches and hubs are just used so to do what, to extend the networks. Okay. So you can see that here when connecting those switches directly like this, it's like I'm just extending the network. Okay, even if they are now LAN A and LAN B, but they will form now the same network. So let me put it down here. Okay, NB. Okay, switches. Okay, and hubs. Okay, are used to extend networks. Okay, what do I mean by that? What do I mean by that? If for instance, let's say that for instance you have a hub, let's say that you have a hub like this. This hub has, let's say, four ports. Okay, this hub has four ports, and you have four devices that are interconnected to that hubs. But you want to connect a fifth device. You have a fifth device that you want to connect to the, let's say that maybe this is hub one. Okay, but you have a new device here, maybe that you have a new user that you should add in your hub network, but there is no port available on the hub. What you can do, a solution will be to you can for instance decide to remove one device. Okay, okay, now let me do it the other way here. You can decide for instance to remove, okay, one device here. Okay, in order to have one port free, you have one port free, and then with that one port, that free port that you will get here by removing, okay, let's say that you remove a device, right? So that port will be free now. So what you are going to do, you can connect a new hubs, okay, to that port which is available now. Okay, and that new port that you will connect will also have, let's say, four ports, right? So meaning that there will be three ports that will be available. You can take the device here that you remove and you connect it here, and your new devices that you want to add, you can add it also here. okay, and it will help you to do what, to increase the network, to extend the network. It is the same network, but because of the fact that the first hub was not having a lot enough port, you use another hub, a new hub 2, in order to extend what your network. And if you want to add more devices, you can do the same thing. You add connect another hub here to the another hub here, okay, and if this hub also has some port, you can connect devices to that, okay. And the same thing from switches, okay. You can replace the hub here by the switches. So if you have a switch, the switch can have maybe lots of port, but if you want to extend the network, you can and add another switch here that will bring more ports. And if also the ports that are the new ports that the new switch is bringing, if they are it's finished, you can connect now a new switch here in order to have more ports. So switches and hubs are used to extend networks. I hope this is clear. So now, okay. So now let us move to the to now the different types of. Okay, let us now move to the different types of. Okay, we have already seen it, but let me mention it again. So we have types of communication. Okay, types of communication. Okay, so when it comes to the types of communication, we saw that we have the half duplex. Okay, half duplex communication, and in a half duplex communication, two devices, okay, can, okay, can communicate. Two devices can communicate, but not at the same time, but not, let me precise it, but not at the same time. So in half duplex communication, two devices can communicate, but not at the same time. So if, for instance, you have PCA here and PCB here, and they are connected like this, okay. If it is a half duplex communication, so when PCA is communicating, PCB is not communicating, he is listening. And when PCA will finish to communicate, it is at that moment that PCA can communicate. So they can communicate at a time, they cannot communicate both at the same time. This is what it means. And we have what? Full duplex communication. Full duplex communication. And in full duplex communication, two devices, okay, two two devices can communicate at the same time. Okay, two devices can communicate at the same time. Okay, those are the types of communication that we have in networking. So now let us talk about the types of messages. Okay, so we have what we call types of messages. Okay, so now when it comes to the types of messages, the first types of message that we have is what we call the unicast message. Unicast message. Okay, and when it comes to the unicast message, a unicast message is defined as a is a one is a one to one communication in a network. So a unicast message is a one to one communication in a network. Okay, so let's say for instance you have a switch like this, and this switch you have, let's say, PCA here connected, and here we have PCB, and here you have maybe PCC. So PCA here wants to communicate with PCA here wants to communicate with PCB. So PCA will send a message, and that message here is a unicast message, and that message will only go to what, to PCB here. Okay, and this message here is what we call a unicast message. Unicast message, because that message is going from one device to one device to another to one device only. So it's a one-to-one communication. Okay, it's a message to send from one device to another one. Okay, this is what we call a unicast message. A unicast message. So we have another one that we call a broadcast message. Okay, we have what we call a broadcast message. So those are the different types of messages we have in networking, in the networks. Okay, so we have what we call the broadcast message. So the broadcast message is a one is a let's say is a one to everyone communication to a net in a network. So is a to um, one to everyone communication, one to one communication in a network. Okay, so basically if I have, let's say, a switch like this, and I have devices that are connected to the switch like this. Let's say here I have A, B, C, and D. So if A sends a broadcast message, so let's say that A is sending a broadcast message. This is a broadcast message sent by A. That message, when you will get to the switch here will understand that this is a broadcast message, and this message is intended to everybody which is connected to the switch. So the switch will send it to everyone like this. So everyone will receive that message. Okay, and it is broadcasted to everyone. This is what we call a broadcast message. Okay, so now we have another one that we call the multicast message. We call the multicast message. Okay, so when a multicast message is a one to a group, okay, or many in a network. Okay, so let me explain. So if for instance you have a switch like this, we have devices that are connected like this. Okay, A, B, C, D. Okay, and let's say for instance that PC A here only wants to send a message to PC B, okay, and PC C only. Okay, so that message is only intended for PCB and PCC. So PCA here can decide to send what we call a multicast message. So the PCB and C here form what we call a group, okay, of devices. So now when the PCA will send that message, will send it to what we call a multicast address. But that multicast address is understood by PCC and PCB and C. So now when the switch will receive it, okay, the switch will understand that, okay, this message I only have to send it to what, to PCB and PCC, but PCD will not receive it because PCD is not part of the group. That's why is a one is you can define it here as a one to a group or many devices in a network, but not all. Okay, I can add here but not all in order to make it clear. Okay, so a multicast message is a one to a group or many in a network, but not all communication. This is how we can define a multicast message. Okay, then we have another one that we call anycast, that we call the anycast message. But when it comes to the anycast message, this one I have a great example. Okay, so anycast message is defined is one to the closest to the closest or the nearest communication in a network. Okay, so now you remember, let me take an example. You know that I can guess that you ordered a lot of ride already with Bolt. Okay, for instance, when you're ordering a ride with Bolt, and you want to go, for instance, to Malam, okay, and you are at Aquateman, for instance, you want to go to Malam, and you are at Aquateman, and then when you request for a ride from Bolt, okay, do you think that if imagine that, for instance, there is a car which is there is a Bolt driver which is just at La Paz, okay, and there is another one which is, let's say, for instance, at Domi, for instance. So now when you request for a ride, do you think that your request will go to the Bolt driver which is at La Paz or the one which is at Domi, knowing that you are going to what, to Malam? Okay, where do you think your request will go? To which Bolt driver your request will go? Do you think it will go to the one which is at La Paz, okay, or the one which is at Domi, knowing that your location is Aquetema, where you are requesting the ride? To which boat the rider the driver do you think the request will go?
La Paz.
La Paz. Why? Because it is the nearest one. You understand? So there is no way of sending your request to a boat driver which is very far away, because it will take time to make it to you where you are. Okay, it will take time from that boat driver to come and pick you up. Okay, so the bot app is made in such a way that when you request for a ride, the request will go to the nearest bot driver which is there, so that if there is a bot driver which is just close to you, automatically it will receive that and it will get to you very fast, and it will pick you up and it will take you to your destination. And this is basically the same thing with the anycast message. So now, do you think if for instance this is you, okay, you are here, you are connected to the network, okay, and then you are connected to the network, and then this network here, to this here we have for instance a server. So a server is let's say is a device that provides services. Okay, so we have different types of servers. We have servers that that can provide file services, email services, or many the servers can provide many services. But now imagine for instance, to here we have what, switch one. Okay, to switch one, I have a file, I have a server, and that server provides video services, meaning that PCA here want to access a video, okay, but that video is hosted or stored in server one here, but now I have, let's say that for instance, other switches like this, and then somewhere here I have another server, okay, which is maybe far away from the where PCA is located in the network. So this server is also a server that provides video, okay, and this is server 2. So both servers are providing the same service, which is what, providing videos to the users that are in the network. But now there's one server 1 is close to what, to PCA, and server 2 is very far away from PCA. So now when PCA will request from a video, do you think that the request will go to the server which is to server 2 or server 1? Based on the example that I gave and what we have agreed, you can understand that the request will go to the one which is close, the nearest server. Because if the request goes to the nearest server will respond in a very faster way, and the video will get to the PCA. The response will get really faster to PCA. Okay, and this is how it works. So now in networking we have the concept of what we call the content delivery. We have the concept of the content delivery. Most of the time people thinks that, okay, when you are accessing something on internet, you are accessing a server which is very far away from you. Not really. Okay, for instance, if you are accessing Amazon stuff, okay, Amazon has data centers where they have servers that are located around the world, and in Africa here Amazon has servers that are located in South Africa. So most of the time when you are sending some request to the Amazon website or Amazon server, Amazon's website on Amazon stuff, okay, and you are located in Africa, your request will go to the Amazon data center or Amazon servers that are located in South Africa. This is how it works, and this is the concept of the content delivery concept, because this is related to what we call also the user experience. Because if the server is far, it will take time from that server to answer you, okay, and most of the time I don't know if you notice it, I'm pretty sure you came across this case where for some time when you are browsing on your laptop, you want to access something, but you notice that the thing is just turning like this. I mean, it's looking for where the server is, and you are expecting a response, but it's taking time from the web page to show up. This may be caused not only by a network issue, but by the fact that also maybe the server that you are trying to access is very far. You understand? That's why it's taking time from the web page to show up on your laptop. But if the server that you are trying to access is very close to you, automatically the response will show up and you will see it. And your quality, your user experience will be great. I think your user experience, you'll be happy noticing that okay, the moment you click on the on your on you click on from accessing that service, the service is provided to you, and you will be happy. Okay, this is what we call the content delivery concept. Okay, and these most of the time this unicast message, this is how it works. So the unicast message is a message which is sent to the nearest or the closest. Okay, is a one. Okay, is a one to the closest, is a one to the closest or the nearest communication in the network. This is how we define it. Okay, so now those are the types of messages that we have in networks. So we have the unicast. We talked about the unicast message. Okay, we talked about the broadcast message. Okay, we talked about the multicast message, and you also talked about the unicast message. Okay, so now let us talk about what we call the collision domain. Okay, let us talk about the collision domain. Okay, so now a collision domain is an area where a collision can occur. Okay, or it is, or we can also define it, it is the area which is impacted by a collision. Okay, okay, then I remember that we define a collision. Okay, basically a collision is when two messages crash, or collide. Okay, so now this most of so far when this comes to, well, regarding the collision, okay, we talked about it when we were looking at what the hub. Okay, so if I have the hub like this and I have devices that are connected to the hub like this, for instance A and B, and okay, let's say that maybe we have another device here C. If A and B communicate at the same time, it will create what? A collision, because the messages sent by A here, okay, and messages sent by he here, they will collide here, meaning that they will collide here, and they will crash. There will be a collision here. But as I said, the collision is something which is bad. Okay, but when that collision will occur, it will affect all the devices that are connected to the hub, meaning that the other devices here, okay, that the other devices here that are connected to the hub will be impacted by the collision, meaning that they will not be able to communicate or send and receive messages. So PCA here will not be able to send and receive messages. PCC here will not be able to send and receive messages. PCB here also will not be able to send and receive messages. All the hub here will be impacted by that collision, meaning that the hub will not function well anymore, and it won't be able to process messages. Okay, so now the fact that the devices here and the hub here that are all impacted by the hub, we can consider that the hub here represent what? A collision domain. So this is what we call a collision domain. Okay, so now the hub by itself represent a collision domain. Okay, let me say it here. So the hub, okay, represent a collision domain. Okay, all the ports of the hub belongs of the belongs to one collision domain, to one collision domain. Okay, so let me explain. I say that here we have the hub, devices that are interconnected like this. Okay, if A and B here communicate at the same time, a collision will occur, and it will in fact the hub. All the ports here will be impacted by the same collision created or provoked by what? By PCA and PCB communication. Okay, the same communication collision will impact all the port of the all the port of what, of the hub here. That's why I say that all the port of the hub belongs to one collision domain. All the port of the hub belongs to one collision domain, and the hub itself represent one collision domain. The hub represent a collision domain one only. The hub itself represent one collision domain. The hub itself represent one collision domain. Let me precise it. Okay, so all the port of the hub belongs to one collision domain. I hope it is clear. So now, uh, okay, so now we are, when it comes to the collision domain, we will see it for all the different devices. So we saw a collision domain when it comes to the what, to the hub. So now when it comes to the when so this collision domain when it comes to the hub. Okay, so now when it comes to the switch. Okay, when it comes to the switch, for instance, when it comes to the switch. Okay, so if you have a switch here, and to this switch we have what, devices that are connected. Let's say we have PCA, PCB, and we have maybe a hub here. Let's say that we have a hub connected to the switch here. Okay, so now you know that collision occurs only on devices that support what, alpha duplex communication. So let's say for instance we have what, a devices that are connected to the hub here, maybe PCC and D. Okay, and let's say that PCC and D, okay, and PCD communicate at the same time. Okay, but this is the hub, or this is a hub which is here. So because it is a hub, and the hub have noticed that there is two communication that occurred, so there is a collision that will occur on this hub, but that collision will affect all the port of the hubs here. Okay, but now you remember that when a collision occurs, okay, the hubs generate a bad signal, and that bad signal will be generated and sent to all the devices that are connected here, and that bad signal also will make it to the switch, to this port of the switch. But this port of the switch here is able to contain the bad signal, meaning that when you will receive that signal, it will not take that signal and send it to the other device that are connected to the switch. So here it is a switch. Okay, SW here means switch. So that bad signal that the switch is receiving on this port here, coming from the hub, the switch here will contain that bad signal on this what, on this port only, meaning that that bad signal that represent the collision will only affect what, this port of the switch, and the remaining port of the switch here will not be affected by the collision. So I can consider that this side as what, as a collision domain. So this is what we call a collision domain. So, and this port of the switch is impacted by what, by the collision. So for the switch, we used to say that each interface of the switch is or belongs to one collision domain. Okay, so each interface of the switch, each interface, okay, of the switch belongs to one collision domain. Okay, so for instance, if I was having, let's say, another switch, another hub maybe connected to this same switch here, and I have devices that are there, and those devices communicated at the same time, and the collision occur, that collision will generate a back signal that will impact this port of the switch, but that bad signal or that collision will be contained only on this side, and this interface of the switch here will be considered as one collision domain. So each interface of the switch is considered as one collision domain. I hope this is clear. Okay, so the switch here, let me write it, the switch, okay, okay, contains the effect of a collision. Okay. So now let us talk about the router. So we talked about the switch, the hub, the switch, and let us now talk about the router. Okay. So now if for instance I have a router like this, okay. So okay, let me just put the statement first. So when it comes to the router, each interface of the router, each interface of the router belongs to one collision domain. Because of the same concept, each interface of the router can contain the effect of the collision. Okay, each interface of the router contains the effect of the collision. Okay, so let me explain, let me give you an example. If for instance we have a router, okay, let's say that we have a router like this, and this router here we have, let's say you have, let's say a hub connected like this, a hub connected here, and you have devices that are connected to this hub. Let's say here I have PCA and PCB, and they communicate at the same time. It will create what? A collision. That collision will generate a bad signal that will be sent to all the devices. That bad signal will get to the port of the router here, but that what? That signal will be contained by the router on this port only. So if the router has other ports that are present here, the other port here, the signal, that bad signal, that collision will not affect the other port of the router here, meaning that the collision will be contained only on this port here. That's why I'm saying that each interface of the router contains the effect of the collision. So, therefore, each interface of the router belongs to one collision domain. Okay? I can see that Pamela raised her hand. So, Pamela, you want to say something?
Yes, I wanted to find out how long is the lecture, please?
How long is what?
How many hours are we doing per session?
Yeah, normally it's 2 hours. So because of the fact that we start at 8:10, so we'll be closing soon. We'll be finishing soon.
Oh,
Okay.
okay, all right.
It
Okay.
only
Thank
remains
you.
one thing that I'm talked about, and after that we are done. But normally the session is 2 hours.
Okay. Okay, all right. Thank you.
Okay, good. So now this is about what the collision domain. So the last thing that we talked about, okay, after this we'll close. Okay, so the last thing that we talked about is what we call the broadcast domain. Broadcaster domain. This is the last thing that we talked about today. So now a broadcast domain is the scope of the broadcast message of the broadcaster is the scope of the broadcast message. Okay, the broadcast message basically is the broadcast domain refer to the area that the broadcast message can cover. Okay, it refers, okay, let me say it like this, it is more clear. So it refers to the area that a broadcast message can cover. Okay, so now when it comes to the hub, so now we talked about each device again. We did it the same thing that we did with the hub. When it comes to the collision domain, we do the same thing for the broadcast domain. So when it comes to the hub, okay, the hub represent a broadcast domain. Okay, the hub okay, represent a one broadcast domain. Okay, one broadcast domain. Represent one broadcast domain. Okay, why am I saying that? Because if you have devices, for instance, that are connected to the hub like this, okay, and let's say that here we have A, B, C, D, okay, so based on the fact that I said that if PCA is sending a broadcast message, I said that the broadcast message is a message which is sent to what? To all the devices. Is a one to everyone communication is a network in the network. I said it before. Okay, so a broadcast message is a one to is a message which is sent, which is used in a one to everyone communication, meaning that if I want to send a message intended to all the device connected to this hub, I can use a broadcast message. But now when that broadcast message will get to the hub will do what? You know the default behavior of the hub, how it behave by default. The hub will just take that message and send it to everyone, meaning that the hub will do what? It will broadcast the message to all the devices that are connected. So now it means that all broadcast message will be able to get to each device. It will be able to get to all the devices that are present in the network. So in a certain way, we can say that the broadcast message is covering the whole network. So because all the devices in the network received that message, so we can say that okay, like this, the hub here represent one what we call a broadcast domain. Okay, because the broadcast messages have been able to be received, have been able to get to all the device in this what in this hub network. Okay, and this is one what we call a broadcast domain. So all the port of the switch, all the port of the hub belongs to one broadcast domain. Okay, all the port of the hub belongs to one broadcast domain. Okay. Okay, so now we have let us now talk about the okay the switch now. Let us now talk about the switch. Okay, so now when it comes to the switch also, the switch represent one broadcast domain. Okay, why? Because if you have a switch like this, okay, and you have devices that are connected to the switch, okay, here A, B, C, D, and PCA wants to send a broadcast message so that everyone can receive it. The switch here, one receiving that message, that broadcast message, will understand that there is a broadcast message and you will send it to everyone here. And all the devices here will be able to receive that broadcast domain, that broadcast message. And this is what the switch itself represents, what we call a broadcast domain, because the message was able to cover what the whole area. Okay, this is what we call the broadcast domain. So all the port of the switch belongs to one broadcast domain. All the port of the switch belongs to one broadcast domain. So let us talk about the router. Okay, so it now when it comes to the router, interface uh, each interface of the router, okay, belongs to one broadcast domain, belongs or represent one broadcast domain. Okay, so now if for instance let's say that okay that you have a router here, and here we have a switch, and you have devices that are connected here, let's say A, B, C, and here you have what, a hub, and you have devices that are connected here on this hub. So now let's say that for instance PCA here is sending a broadcast message, which is a message intended to everyone. When the switch will receive it, it will understand that the message is intended to everyone. It will send it to everyone. So it will send it to B here, it will send it to C here, it will also send it to the cable here which is connected to the router. But now when the router will receive that broadcast message on this interface. But now routers by default they does not forward broadcast messages. Okay, let me put it down here, NB. Okay, by default, okay, a router does not forward or process broadcast messages. Okay, it blocks broadcast messages. Okay, so meaning that if for instance when the switch will take that same broadcast message, send it here, okay, and the router will receive that broadcast message on this interface, the router is going to block or contain that broadcast message here. You understand? So the router will not take that broadcast message and forward it to the other interface here where there is another network connected, okay. And this is what we call with this is what we call and then this area here is what is a broadcast domain, represent what a broadcast domain. So this interface of the switch of the router here belongs to one broadcast domain. So the other side here we have a hub. Here we have pc d, e, and f. So if d and e communicate at the same time, sorry, if this sends what a broadcast message here, that broadcast message will be sent to everyone here that are connected to the hub, but the hub will also send it here. But now when that broadcast message will make it to the router here, because of the fact the router blocks or it blocks broadcast messages, it does not forward broadcast messages, it will contain that broadcast messages here. And this interface here will, so the broadcast message was able to touch this interface of the router, meaning that this interface of the router is part of the broadcast domain. I hope it is clear. So now we can see that okay, this interface of the router belongs to one broadcast domain. Are you okay? So let me say it again. The broadcast domain here is the scope of the broadcast message. It refers to the area that the broadcast message can cover. You can see that the broadcast message here can cover can go from PCD to PCE to PCF, and it can also touch this interface of the router, okay, which is defined also have let's say the ADs of, for instance, of the network, okay. And this is what we call, so each interface of the router here belongs to one broadcast domain. So it means that if for instance you have four, if you for instance you have a router, okay, that has four interfaces like this, it means that each of those interfaces it represent what of the router represent a broadcast domain. So right now on this router which is here, I have four broadcast domain, okay. So now a broadcast domain, okay, a broadcast domain, let me put it here, NB. A broadcast domain, okay, represent a network, okay, represent a network. So basically a broadcast domain is just a network, okay. A broadcast domain, domain broadcast domain equal to broadcast domain equal to network, equal to network, or equal to LAN, okay. Because if you can see, look at here I have a LAN, and in this LAN the broadcast messages have been able to cover or to touch all the device in this LAN, okay. So we can consider this broadcast domain to be what, a network. So a broadcast domain basically is a network, okay. So now this is it for today's session, okay. So this is the last thing that we talked about. But now why do we need to know all this? Why do we need to know that, okay, what is a broadcast domain and what are the collision domain? It is because of the fact that during the international exam, the CCNA, you can come across this kind of example where this kind of question where they will ask you, okay, what are the different what are the collision domains and the broadcast domain that you have in a network topology, for instance. So let me give you an example, okay. Let me give you an example. Mm, okay, now let me just draw it. Okay, let's say for instance I have this network. Okay, I have a router. This is a router. Okay, and I have a switch, and I have a device which is connected here. So PCA, PCB, okay, and I have PCC. So this is a basic network topology. So based on everything that we saw so far, in this network topology, how many broadcast domain do we have, and how many collision domain do we have? This is the kind of question you may come across during the international exam. So this is a network topology. Based on everything that we have seen so far, can you count the number of collision domain and broadcast domain that we have here? What do you think? Yes, Pamela. I'm gonna start with Pamela. Pamela, what do you think? How many collision domain do we have?
Collision domain zero. Broadcast domain 1.
So we have, Pamela said we have one collision domain 0 and broadcast domain 1. Okay.
Mm.
So
Yes.
Selam,
For match day 13 has been postponed. It was meant to be.
yeah, Selam, we can hear you. We are listening to you. How many collision domain do you have?
Yeah,
How many broadcast domain?
I will pass on this one because I wasn't following.
Okay, good, good. So now, Pamela, you said that we have uh, zero collision domain and we have one broadcast domain. I mean, let's start with the broadcast domain. Let's start counting the broadcast domain. I said that, okay, as I said that all the port of the switch here belongs to what, to one collision domain, to one broadcast domain, and one interface of what, one interface of the each interface of the router belongs or represent one one broadcast domain. Okay, so in order to find the broadcast domain, if you want to find the broadcast domain, what you can do is just imagine that there is a device that sends a broadcast message in the network. So if there is a device, let's say that for instance PCA sent a broadcast message, how far that broadcast message will go in the network. So when the switch will receive it, it will send it to PCB here. The switch will understand it's a broadcast message. It will send it to PCB. It will send it to PCC. It will also send it to the router here. But because it is a broadcast message, the router do not forward broadcast messages, so it will contain it on this interface here and it will block it here. So now these here can represent what we call a broadcast domain. And as you said, we have one broadcast domain, and it is true. We have one broadcast domain. Okay, but now when it comes to the collision domain, okay, I said that when it comes to the collision domain, the collision domain occurs only if you have a device that works in alpha duplex. Okay, but right now we have devices that are connected to the switch, and the switch support what, full duplex communication. And those laptops that are there, they are more than one. They also support full duplex communication. So now, in order to find the number of collision domain, what you can do, you can assume, for instance, that okay, if I was having a hub in between, if I was having a hub in between, just a minute. Okay, okay, okay. When it comes to the collision domain, assuming that you are just assume that, okay, or just imagine that for instance you were having a hub in between the switch and PCB here. And if for instance there is a collision that occurred on that hub, so this in your imagination, okay, you are imagining that between the PCB and the switch here there is maybe a hub which is present. And if there is a hub here, that hub can create what, a collision. And if that collision occur, that collision will affect what, it will affect this port of the switch and will affect PCB here. Okay, this is the first case, okay, in which we can have a collision in this example. But now there is also the case where I said that the collision can be created by the device which is functioning what, in half duplex. So it may happen that maybe this device PCB here, they configure it in such a way that it is working in half duplex. And if it is working in half duplex, it means that collision can occur on this in this over this link here. You understand? And if the collision occurred, it will only affect this interface of what, of the switch here. So it means that, as I said, each interface of the switch represent what, a collision domain. Okay, so each interface of the switch represent a collision domain because of the fact that if there is a collision that occurs here, that collision will only affect this part of the switch. So it means that this is represent what, one collision domain, and this interface of the switch also here represent one collision domain. Okay, and this interface also of the switch represent one collision domain. As I said, each interface of the switch represent one collision domain, and each this interface also of the switch here represent what, one collision domain. But now if there is a collision that occurs on this link, it will affect this interface of the switch and this interface of the router, the same collision. The same collision will affect this interface here. Let me take another color. The same collision that will happen, that is happening here, will affect this interface of the switch and this interface of what? Of the router, the same collision. So here also we have another collision domain. So how many collision domain we have in total? We have one, two, three, four collision domain in total. So meaning that here, Pamela, you got it wrong. So here we have four collision domain. Yes, Pamela, you want to say some?
So I thought that the half duplex, they only communicate. There's no send and receive. And if it's only sending, then there's no cause for collision. It's when there's a send and receive that there will be a possibility of collision.
But yes, if this interface, see, if this interface which is here, okay, as I said, if this interface of the switch here is, I say that it support half and full duplex, right? And the device which is here, the laptop is here, is functioning in half duplex. Collision can occur, yes or no?
Yeah, if it's full duplex, yes, collision can happen. But
Ye-
if it's half, sorry, if it's full, it can happen. But if it's half, it cannot happen
So
because it's only one way.
yeah, this is it. So if the interface of the switch is in full duplex and the laptop here is working in half duplex, collision may occur. Okay, but if the interface of the switch is working in half duplex and the switch also is the laptop is also working in half duplex, collision will not occur. You understand? But I'm taking the case where collision can occur in order to counter the collision domain. So if there is a collision that occurred on this link, it will impact only this interface of the switch. Do you understand it?
Okay, I get you.
Yeah. So
Okay,
yeah,
okay.
by any chance, yeah, let me say it like this: if by any
The,
chance there's maybe
the
someone who
worst
made,
case scenario.
yeah, well, let's say yes, that's it, the worst case scenario, or someone
Okay,
misconfigured something and there's a collision that happened. That collision will
okay.
impact what? It will impact the device and this interface of the route of the switch. Do you understand? Okay.
Yes,
So
yes,
now imagine that
yes.
there is a worst case scenario on all those links. So those
Okay,
collision will affect what? It will only affect those interfaces. You understand? Okay. But
okay,
now we
okay.
can count here. We have one collision domain, second,
Mm,
third, and fourth one, and we have one
okay,
broadcast domain.
okay,
So now
okay,
let me take another one. Okay, let me take another one,
okay.
the last one. So let's imagine that we have, okay, we have another router like this, and connected to what? To another router here. Okay, and then this router is connected to the switch here, and we have another switch here. We have a device which is here. We have a device which is here, and here to this router we have a hub which is connected to the hub, and we have devices that are here. Okay, so now here, how many broadcast domain do we have and how many collision domain do we have? Okay, Pamela, are you done? Just to base yourself on everything that I said. Each port of the switch belongs to one collision domain. All the port of the switch belongs to one broadcast domain. Each port of the router belongs to one broadcast domain, and each port of the router belongs to one collision domain. All the port of the switch of the hub belongs to one collision domain. The hub itself represents a collision domain, and all the port of the hubs also belongs to one broadcast domain. So based on those statements, it will be easy for you to find those collision and broadcast domains. Just you make use of those statements, and it will be easy for you to find them. And just imagine, as I said, you will find them. Okay. So now, yes, Pamela, are you okay now? Can we go ahead? Hello, Pamela. Are you there? Yes. Okay. Selam said.
Sorry, sorry, I was muted.
Yeah. Okay. So, did you find them?
So for the hub, there are three interfaces. So that'll be three broadcast domain,
The hub.
and then yeah, for the hub side, three broadcast domain.
No, the total one. I mean, the total from everything. How many broadcast domain did you find?
One, two, three, four, five.
Five broadcast domain. And the
Yes,
collision.
please. Solution one, okay, two, three, four, five.
Five also. Okay. Let us count together now.
Yeah,
As I said,
okay.
as I said, the goal is to find them. You can just imagine. So imagine that this PC here sends a broadcast message. The broadcast message, when you will get to the switch, what the switch will do with that broadcast message is a broadcast message. It will send it to everyone. So the switch will send it to this device, and you will also send it to the router here. But when the router will receive it, the router will block that broadcast message here because the router does not forward the broadcast messages. So based on the fact that that broadcast messages have been able to cover all those or to touch all those devices, all those ports, we can say that this. I mean, we can say that all the as I said, all the port of the switch belong, all the port of the hubs belongs to one collision domain. And you can also notice, you can also find it by the fact that each port of the router, this is a router, okay, this is router 1, this is router 2. So this interface of router 1 here is this the interface of router 1 here belongs to, it represents one collision domain, it belongs to one collision domain. So we can say that everything which is connected to this port belongs to what, one collision domain. Okay, so this is one broadcast domain, this is one broadcast domain. Okay, this is one broadcast domain. So now this interface here, or the other interface of the switch here, of the router here, also belongs to one broadcast domain. So we can see that here we have one broadcast domain, and this interface of router 2 here also belongs to the same broadcast domain. Because if you have, for instance, a device in, if you imagine that we have a switch maybe in between here, so and this switch is processing a broadcast message, that broadcast message will be sent like this and sent like this, meaning that those two interfaces will receive the same broadcast message. So those two interfaces, even if they are found on different routers, but they belong to the same broadcast domain. So we have a second broadcast domain here. But now, as I said, the statement, each interface of the router represents a broadcast domain. This interface of the router will represent what, a broadcast domain. So everything down here belongs to that broadcast domain. Why? Because if this device which is here, this one here, sends a broadcast message, how far that broadcast message will go? The switch will understand it is a broadcast message. It will send it to all the devices like this. The router will block it here. But now, when the broadcast message will be sent like this to the other switch here, the other switch also will receive it and will understand it's a broadcast message. It will send it like this, and this device will be able to receive it. So now here too we have what, another broadcast message, broadcast domain. So this is the third broadcast domain. So right now we have one, two, three broadcast domain. I hope it is okay. So now, concerning what, the collision domain, let me take another color. Okay, so when it comes to the collision domain, I said one each inter I said all the inter if they okay, if there is a collision on the hub, all the interface of the hub will be impacted by that collision. Do you understand? So it means that all the port of the hub here belongs to what? To one collision domain. So if there is a collision here, all those ports here will be what? Will be affected by that collision. So this is what we call a collision domain. And the collision will generate what? A bad signal. When that bad signal will make it to the router here, the router will contain that signal, meaning that each interface of the router here represents what? One collision domain. So this is actually one collision domain here where we have the hub. It is one collision domain. So now imagine that the connection between the two routers here. Imagine, for instance, that you were having a hub and there is a collision between the two routers here. If there is a collision here, the collision will do what? It will impact this interface of the router and the other interface of the router. So it means that here we have what? Another collision domain. Okay, another collision domain. So this is another collision domain. Okay, and now down here, if I have a collision, okay, if I have a collision, okay, let's say here first, this on these devices here, between the switch here and the laptop down here, if I have a collision here, that collision will only affect this interface of the switch, because I said each interface of the switch belongs to one collision domain. So this is one collision domain, and this interface also here, if there's a collision is which occurs here, it will impact this interface and this interface. So this one represents what? Another collision domain. So we have one collision domain, two collision domain here. This interface of the switch here also represents one collision domain. So we have a third collision domain here. But now this interface also of the switch represents what? Another collision domain. But now if there is a collision domain that occurs here, it will impact this interface of the switch and this interface of the router. So this could be represented as another collision domain. So how many collision domain do we have in total? We have one, okay, we have one, we have two, we have three, we have four, we have five, and we have six. So here we have six collision domain in total. Okay, and this is how we calculate it. Okay,
Okay.
so I hope it is clear. So now what I'm going to do, I will send you a file which is having a bunch of exercises that will help you to find the broadcast domain and the collision domain. So I'm expecting you to do that. Okay, you have to do that, you work on it, so that next time when we have another session, we'll work through those exercises and then we'll move on to the what, to the new topic. Okay, if you have time. Uh,
Okay.
Okay, so thank you for
Okay, sure.
thank you for being present from being present. I hope this session was very interactive, was very informative, and you learned something new today. Hope to see you next time.
Okay. Thank you very much.
Sure.
Yeah,
Thank you.
welcome.